Something very strange happened on November 19th, and it wasn't what NASA said. It was what they refused to say. For nearly 2 hours, they talked about 3I Atlas. They showed distant, blurry images. They listed instruments and missions. They used scientific jargon and careful language, but they revealed almost nothing. 20 spacecraft had direct observations of this interstellar visitor, 20 different vantage points across the solar system. Yet we saw maybe 5 usable images, all of them dim, all of them distant, all of them carefully selected. If you want to understand what NASA is really hiding about 3I Atlas and why their silence might be more important than their words, hit that like button and let's analyze what actually happened during that live stream. Because the story they're not telling is far more interesting than the one they are. When NASA announced they would host a live briefing about 3I Atlas on November 19th, the anticipation in the astronomical community was enormous. Finally, we thought, we'd get real answers, clear images, detailed data, concrete explanations for all the anomalies that had been piling up for months. An interstellar visitor, the third one ever confirmed. An object that has traveled through the galaxy for billions of years, carrying information about stellar systems we've never seen, about planetary formation processes we don't understand, about cosmic chemistry from the early universe. This should have been one of the most important scientific briefings in years. Instead, what we got was something entirely different, something carefully controlled, something that felt less like a scientific update and more like damage control. The live stream started normally enough, professional graphics, multiple NASA scientists arranged behind a panel, the usual formal introductions. But within the first 10 minutes, something became very clear. This briefing had been meticulously planned, not to inform, but to manage expectations, not to reveal discoveries, but to shape the narrative. Before they showed a single new image, before they presented any new data, the panel spent extensive time doing something unusual. They were actively denying rumors, addressing speculation, emphasizing repeatedly and with careful deliberation that 3I Atlas is just a comet. Just a comet. They used that exact phrase at least 7 times in the first 20 minutes. Think about that for a moment. When was the last time you watched a NASA briefing where scientists spent more time telling you what something isn't rather than explaining what it actually is? When astronomers discover a new pulsar, they don't spend half the presentation insisting it's not an alien lighthouse. When they find exoplanets, they don't repeatedly stress that it's definitely not artificial. They present the data, they explain the science, they let the evidence speak for itself. But with 3I Atlas, the greatest priority of the entire event seemed to be managing public perception, controlling the conversation, making absolutely certain that everyone walked away thinking, normal comet, nothing unusual, move along. That defensive posture, that need to reassure before revealing, immediately raised questions. Because if everything is truly normal, if there's genuinely nothing extraordinary happening, why the elaborate preparation to convince us of that fact? As the briefing continued, the pattern became more obvious. The scientists moved through what felt like rehearsed talking points, carefully scripted explanations, safe, comfortable territory. Comets behave like this. Comets release dust like that. Comets come and go all the time. Each statement was technically accurate, but it was the repetition that felt strange, the emphasis, the way they kept circling back to these basic reassurances as if the audience needed constant reminding that comets are normal objects. And what made this even more peculiar was what they didn't emphasize. The truly interesting details, the anomalies, the characteristics that make 3I Atlas different from every other comet we've studied. Those details were mentioned, briefly, almost in passing, and then quickly buried under layers of, but this is all normal explanations. Here's what really troubled me about the briefing. NASA claimed that 20 different spacecraft had observed 3I Atlas, 20 separate missions scattered across the solar system, each with unique instruments, each capturing data at different wavelengths, each providing a different perspective on this interstellar visitor. Let me list them for you. Hubble Space Telescope, James Webb Space Telescope, the Lucy mission currently on its way to Jupiter's Trojan asteroids, the Psyche mission heading toward the metallic asteroid Psyche, Maven orbiting Mars, Mars Reconnaissance Orbiter, and more than a dozen others. This represents an unprecedented coordinated observation campaign, multiple space agencies, billions of dollars worth of equipment, some of the most advanced instruments humanity has ever built, all focused on a single object. The amount of data collected must be absolutely staggering. Spectroscopic measurements across every conceivable wavelength, high-resolution imaging from multiple angles, thermal signatures, magnetic field measurements, particle detection, chemical analysis. We should have been drowning in information, overwhelmed by discoveries. Instead, the Livestream offered a handful of images, maybe 5 or 6 usable frames total. And even those were disappointing. Distant shots showing barely more than a faint smudge against the darkness, blurry halos, indistinct streaks. Nothing that matched the scale or quality of what NASA claimed to have gathered. They talked about science wiggles in the spectroscopic data. They mentioned complex spectrographs and high-resolution image stacks, but they kept the actual visual evidence off-screen. It was like watching a Beto takes weather report where the meteorologist describes incredible storm patterns, references multiple satellites and radar systems, explains atmospheric dynamics in technical detail, but never actually shows you the satellite imagery. Just tells you what the satellite supposedly saw. That's not how science communication normally works. When you have compelling visual evidence, you show it. When you have clear data, you present it. When you've made discoveries, you share them. Unless there's a reason not to. And throughout the briefing, NASA provided plenty of reasons, a constant stream of explanations for why they couldn't show what everyone expected to see. The instruments were pushed beyond their intended limits. The spacecraft had to turn into awkward positions. The angles weren't ideal. There was significant glare. Artifacts were introduced. The data requires extensive calibration. Processing takes time. We don't want to release misleading information. Every single one of these explanations sounds reasonable in isolation. Responsible even. You don't want to rush science. You don't want to present uncalibrated data that might be misinterpreted. But when you stack them all together, when you hear excuse after excuse, reason after reason, justification after justification for not showing the data, a pattern emerges. NASA wasn't explaining why they couldn't show the data. They were explaining why they wouldn't. And that's a very different thing. What made this even more frustrating were the tantalizing details they did mention. Brief references to extraordinary characteristics that were glossed over so quickly you could easily miss them if you weren't paying close attention. They mentioned that 3I Atlas has an unusually high carbon dioxide ratio compared to water. For a comet, that's extremely rare. Most comets in our solar system are water-dominated. Carbon dioxide is present, yes, but is a minor component. For it to be the dominant volatile suggests very different formation conditions, very different thermal history. They mentioned excess nickel compared to iron in the spectroscopic measurements. Again, highly unusual. The nickel-to-iron ratio tells us about the chemical processes that occurred when the object formed. It's like a fingerprint of its stellar nursery, and that fingerprint doesn't match anything from our solar system. They mentioned unexpected polarization patterns in the dust particles being ejected. Polarization reveals information about particle size, shape, and composition. Unexpected polarization means the dust doesn't behave like normal cometary dust. It's structured differently, organized differently. And perhaps most intriguingly, they mentioned the possibility, stated almost casually, that 3I Atlas might have originated in a stellar system older than our Sun. Older than our Sun. Think about what that means. Our Sun is 4.6 billion years old. If 3I Atlas comes from a system that's older, we're potentially looking at material from the very early universe, from the first or second generation of stars, from a time when the galaxy had a completely different chemical composition. That's not just interesting, that's profound, that's revolutionary. That deserves its own dedicated discussion, its own detailed analysis, its own celebration as a window into cosmic history we've never had access to before. Instead, it was mentioned in passing, a single sentence, and then they moved on to safer topics. Why? If you've made a discovery this significant, why rush past it? Why not explore it? Why not explain the implications? Unless you're worried that exploring those implications might lead to questions you're not ready to answer publicly. The pattern of selective revelation continued throughout the briefing. Every time something genuinely interesting came up, every time a detail emerged that didn't fit comfortably into the just a normal comet narrative, the speakers would acknowledge it briefly and then pivot back to familiar territory. Yes, there are some unusual characteristics, but comets are diverse objects. True, we don't see this exact combination often, but interstellar objects might be different. The chemistry is distinctive, but that's to be expected from another stellar system. Each deflection technically accurate, but fundamentally unsatisfying. Like answering, "Why is the sky blue?" with, "Because that's the color we observe." True, but missing the entire explanation. And then there were the technological excuses, the explanations for why the images weren't better, why the data wasn't complete, why everything looked so disappointing compared to what we expected. They explained that some spacecraft had to maneuver into awkward positions to observe 3I Atlas, that these unusual orientations introduced glare from the sun, creating artifacts in the images, that the comet was often too close to the sun from Earth's perspective, making observations difficult. They acknowledged that some instruments were operating at the very edge of their capabilities, trying to detect signals that were almost too faint to measure. That calibration under these extreme conditions takes time and introduces uncertainties. They emphasized repeatedly that releasing uncalibrated data could be misleading, that it could cause confusion, that it's better to wait until everything is properly analyzed rather than showing preliminary results that might be misinterpreted. All of this sounds responsible, professional, scientifically rigorous, but here's the thing. NASA has released preliminary data before. Many times, they've shared uncalibrated images from Mars rovers within hours of receipt. They've published early spectroscopic measurements from exoplanet atmospheres while analysis was still ongoing. They've shown raw telescope data with clear disclaimers that interpretation is preliminary. The scientific community understands that early data comes with caveats. The public understands it too. We're not children who need to be protected from complexity or uncertainty. So why the extreme caution now? Why the reluctance to share anything beyond carefully selected, heavily processed images that show almost nothing? What are they worried we might see if they showed us the raw data? About halfway through the briefing, someone asked a direct question. A very reasonable question that many viewers were probably thinking. Can you show us the highest resolution images captured by Hubble or James Webb? There was a brief pause, the kind of pause that speaks volumes, and then came the answer. Those images are still being processed. The resolution isn't quite what we hoped for due to the object's distance and brightness. We'll release them when they're ready for public consumption. When they're ready for public consumption, not when they're ready for scientific analysis, not when they're properly calibrated, but when they're ready for the public to see. That phrasing reveals something important. It suggests that the images exist, that they've been captured, that NASA has seen them, but that they've made a decision about what the public should and shouldn't see right now. That's curation, that's information management, that's controlling the narrative. And it raises an obvious question. What's in those images that NASA doesn't want us to see yet? The briefing continued with more technical discussions, orbital mechanics, spectroscopic analysis methods, thermal modeling, all perfectly valid science, all perfectly boring compared to what everyone actually wanted to know. What does this thing look like up close? What's its surface like? Are there any structures, any features that don't fit cometary models, any signs that it might be more than just a chunk of ancient ice and rock? None of these questions were directly addressed. Whenever someone tried to steer the conversation toward the genuinely interesting anomalies, toward the characteristics that make 3I Atlas unique, the panel would acknowledge the question and then redirect. That's an interesting point, but we need more data before we can comment. We're seeing some unusual signatures, but it's too early to draw conclusions. The behavior's within the range of what we might expect from an interstellar comet. Notice the language. Too early. Need more data. Within range of expectations. These phrases create a barrier. They establish that now is not the time for those discussions, that we should wait, that we should be patient, that we should trust that NASA will tell us when they're ready. But trust requires transparency, and this briefing was anything but transparent. Toward the end of the live stream, they began wrapping up with summary statements, reiterating the key messages, making sure everyone understood the official narrative. 3I Atlas is a comet, an unusual one perhaps, but fundamentally a natural object. Following predictable physics. The anomalies that some have reported are either misunderstandings or explainable through conventional processes. We're continuing to gather data and will release more information as it becomes available. Professional, measured, reassuring, and completely unsatisfying, because they never actually addressed the core anomalies that have been documented by independent observers around the world. The zero-thrust decay that violates every cometary model we have. The perfect rotational stability that shouldn't exist with active outgassing. The reflective surface patches, the rhythmic cyanogen bursts on a precise schedule, the sudden course change toward Earth's orbital path. None of that was meaningfully discussed. It was acknowledged in the vaguest possible terms and then set aside as requiring further study. But here's what bothers me most about that approach. Independent astronomers, amateur observers with backyard telescopes, have been documenting these anomalies for months. They've shared their data openly. They've published their measurements. They've invited scrutiny and peer review. NASA has access to instruments that are orders of magnitude more powerful than anything available to amateur astronomers. If independent observers with modest equipment can detect these anomalies, NASA's advanced systems must see them in extraordinary detail. So why aren't they talking about them? Why aren't they showing us what they see? There are really only two possible explanations. It's either the anomalies aren't as significant as they appear, and NASA's detailed analysis has found conventional explanations that they're still preparing to present clearly. They're waiting until they can explain everything comprehensively, rather than releasing confusing, partial information. Or the anomalies are exactly as significant as they appear, possibly even more so, and NASA has found something in their detailed analysis that they're not ready to share publicly. Something that requires careful consideration of how to present it, something that might fundamentally challenge our understanding of what 3I Atlas really is. Given the defensive tone of the briefing, given the careful management of information, given the repeated emphasis on just a comment before showing any data, I find myself leaning toward the second explanation. They've found something. Something that doesn't fit. Something that raises uncomfortable questions, and they're not sure how to talk about it yet. When the live stream finally ended, the chat was filled with frustration, disappointment, confusion. People who had tuned in expecting answers felt like they'd gotten a carefully orchestrated non-answer. Why didn't they show us better images? What about the thrust anomaly? Why do they keep insisting it's normal when everything about it seems unusual? What are they hiding? That last question appeared again and again. What are they hiding? And maybe that's unfair. Maybe NASA genuinely believes they're acting responsibly by waiting until all data is fully analyzed before making strong claims. Maybe they're trying to avoid the mistakes of the past, the premature announcements that later had to be walked back. But transparency doesn't require certainty. You can share data and acknowledge uncertainty. You can show images and admit you're still interpreting them. You can present anomalies and explain that you're working to understand them. What you shouldn't do is promise a major update and then deliver almost nothing. You shouldn't hype an observation campaign involving 20 spacecraft and then show 5 blurry images. You shouldn't claim to have unprecedented data and then explain why you can't share it, because that creates exactly the environment where speculation thrives, where conspiracy theories grow, where trust erodes. If NASA's goal was to reassure the public and dampen speculation about 3I Atlas, the November 19th briefing achieved the opposite. It amplified concerns. It validated suspicions. It made the silence around this object feel even heavier than before. And that silence, that careful management of information, has become part of the mystery itself. What's particularly interesting is how this approach contrasts with NASA's handling of other recent discoveries. When they found phosphine in Venus's atmosphere, potentially indicating life, they were open about the uncertainty. They presented the data, acknowledged the controversy, invited debate. When they detected the first interstellar object, Oumuamua, they were transparent about its bizarre characteristics. They showed the data that demonstrated its unusual acceleration. They openly discussed the possibility that it might not be entirely natural, even if most scientists favored natural explanations. But with 3I Atlas, there's a different energy, a more guarded approach. As if this object, this discovery, requires a level of information control that other extraordinary findings didn't. Why? What makes 3I Atlas different? What about this particular interstellar visitor requires such careful narrative management? I don't claim to know the answer, but I can tell you what the data suggests. Every single anomaly documented by independent observers remains unexplained by the official narrative. The behavioral characteristics that violate standard cometary physics haven't been addressed. The structural features that don't match natural formation processes haven't been discussed. And most significantly, the vast majority of data collected by those 20 observing spacecraft hasn't been released. It exists. NASA confirmed it exists. They just won't show it to us yet. They promise it's coming. Soon. When it's ready. After proper analysis. But they've given no timeline, no specific date, no clear indication of what criteria must be met before they'll share what they found. That open-ended deferral is exactly how information gets buried, how uncomfortable discoveries get quietly forgotten, how extraordinary findings get normalized until they no longer seem worth discussing. And maybe I'm being cynical. Maybe in a few weeks or months, NASA will release a comprehensive report with all the data, all the images, all the analysis, and everything will make perfect sense. Maybe there are boring, conventional explanations for everything, and they're just taking their time to present them clearly. But based on that November 19th briefing, based on what was said, and more importantly what wasn't said, I'm not optimistic. Because when scientists are confident in their understanding, they share it. When data supports a clear conclusion, they present it. When discoveries are genuinely routine, they don't require 2 hours of careful reassurance that everything is normal. The defensive posture suggests uncertainty. The information control suggests something unexpected. The repeated emphasis on just a comet suggests they're worried people might think it's something else. And that worry, that concern about public perception, that careful management of the narrative, tells me that 3I Atlas might be far more interesting than NASA is currently willing to admit. So what happens now? What's the next chapter in this story? 3I Atlas continues its journey through the inner solar system. It's currently being observed continuously by multiple instruments. Data continues to accumulate. Images continue to be captured. Measurements continue to be recorded. All of that information exists somewhere. In NASA databases, in ESA archives, in research institutions around the world. The question is when or if we'll ever get to see it. NASA has promised additional briefings, more data releases, comprehensive scientific papers. But they've given no concrete timeline, no specific commitments. In the meantime, independent observers continue their work. Amateur astronomers continue documenting anomalies. Researchers outside the official narrative continue asking uncomfortable questions. And slowly, piece by piece, the real story of 3I Atlas might emerge. Not from official briefings or carefully managed revelations, but from the accumulated weight of observations that don't fit the comfortable narrative NASA is trying to maintain. Because the truth has a way of emerging eventually. Data can be withheld, but it can't be erased. Images can be delayed, but they can't be hidden forever. And anomalies can be downplayed, but they can't be explained away if the physics simply doesn't support conventional interpretations. 3I Atlas is out there right now, moving through space, behaving in ways that challenge our models, carrying information about its origins that we're only beginning to glimpse. And somewhere in NASA's servers, in their processing pipelines, in their analysis reports, the full story exists. The complete data, the highest resolution images, the detailed measurements, that show exactly what this object is and how it's behaving. We just don't get to see it yet. We're told to wait, to be patient, to trust that NASA will share everything when the time is right. But that November 19th briefing made one thing crystal clear. When it comes to 3I Atlas, silence speaks louder than words, and what they're not telling us might be far more important than what they are. So I'm asking you, what do you think NASA found? Why the extreme caution? Why the careful narrative management? Why the reluctance to share data from 20 different spacecraft? Are they just being responsible scientists, taking their time to understand something complex? Or have they discovered something about 3I Atlas that fundamentally challenges our understanding of what's possible? Let me know your thoughts in the comments. And if you want to keep following this story, if you want to see what independent researchers uncover while we wait for NASA's next carefully managed revelation, make sure you subscribe and turn on notifications. Because this story is far from over. The silence around 3I Atlas is growing louder. And eventually, one way or another, we're going to learn what NASA saw during those observations they're so reluctant to share. The truth is out there, somewhere between what they said and what they didn't say, somewhere in the gap between 20 spacecraft worth of data and 5 blurry images. And we're going to find it. Stay curious, stay skeptical, and never stop asking questions. Because the moment we stop demanding transparency is the moment we lose any chance of understanding what's really happening in our solar system.